Welcome to Scanner Today's Let's Talk AI podcast, where you can hear AI researchers discuss what's going on with AI. This is our latest Last Week in AI episode, in which you get quick summaries and discussion of some of last week's most interesting AI news. I am Andrei Korenkov.
And I am Dr. Sharon Joe. And let's dive straight in. Our first article is titled Microsoft's Zero Infinity Library Claims to Train 32 trillion parameters deep learning models on a cluster of just 32 GPUs. And this is from MarkTech Post. All right. Well, there's a recent announcement by Microsoft, and lo and behold, they open sourced something called DeepSpeed, which is an AI training library that optimizes memory usage under the hood and can help you train very large deep learning models. And so with this Zero Infinity, with the help of Zero Infinity, Microsoft achieved this benchmark of training a model with 32 trillion parameters on a small cluster of GPUs. And this is pretty big, I would say. And I think one thing that is really exciting is that they also showed that they could fine tune a 1 trillion parameter model on just a single GPU. And so this is, I feel like this is thinking of the little people here in academia. We only have one GPU. We can still fine tune this massive 1 trillion parameter model. And I think this is really important, especially as we think through not just, research and enabling people in academia or people without necessarily as many resources as a Microsoft or Google, but also, computing on the edge and all these things where we want to be using less compute, thinking about, climate footprint and all that stuff. This is relevant too.
Yeah, I fully agree. I think personally, I've had some GPU envy sometimes where, I want to experiment with some of these GPT-like transformers, but then I think, well, I don't have however many GPUs they use, so can I even try it? And so I think this sort of technology will be increasingly useful and needed. And of course, we've had similar things before, like gradient checkpointing and then various schemes to make it more tractable to train with just fewer compute. But we may have to use fancier techniques like this as models keep getting bigger and bigger, and GPUs, although they're getting more powerful, are not quite keeping up in terms of the sizes of these things. So yeah, very cool. Of course, just preliminary research. And the number here, 32 trillion, is pretty impressive sounding. Of course, we've seen some trillion level, trillion parameter models in the past from Google and other big companies. But still, a trillion is a trillion.
Yeah, and what's interesting is that they actually use, their engine kind of uses CPU to help with this memory storage, to help with storing the model parameters because it's so big, right? And I find that kind of interesting, like doing this dual, like thinking about the whole system. And of course, we often, when we write this code, we do think about, what can we split up across this whole computer? But it's great that something like this, a library like this, could do it for you.
Exactly. So cool to see this research, very practical, and ideally we need more of this sort of thing. And on to our second research-themed article, quite different. This one, not so practical. The article is DeepMind Scientists, Reinforcement Learning is Enough for General AI. So DeepMind, the company, released a new paper titled Reward is Enough by some of its key people, basically putting forth an opinion that to get to general intelligence, general AI, all you need is reinforcement learning and you need rewards. And it's sort of an overview of these sorts of ideas of where does intelligence come from, how do humans acquire skills, and ultimately concludes that reward maximization and trial and error are enough to develop behavior that exhibits the kind of abilities associated with intelligence. So personally, I was pretty nonplussed. And I think this was the common reaction of like, okay, well, sure, it may be enough, but, random search is enough when you have enough compute to do anything, right? So it's not a practical suggestion. We don't have millions of years of evolution to get there. And of course, humans exhibit all sorts of learning. We do supervised learning and supervised learning. I think it's pretty weird to put forth this point. I don't really know kind of why they even did it. What do you think, Sharon?
Well, I'm not really surprised because I think DeepMind has been taking this stance quite strongly with their research anyways. And I guess this is just codifying it a bit. And one thing I guess to reflect on is, if reward is enough, great. But what about the data behind that reward? For example, an agent that you're doing imitation learning, for example, and maybe you get some kind of reward from an environment that is in simulation, but does that actually extend to the real environment? I feel like saying reward is enough. Maybe reward is necessary to get to AGI, but not sufficient. I would want to see some nuance there because I'm not particularly convinced, but I also understand that this is the stance that DeepMind very much has been taking throughout the years. And I'm glad that there is a company that is pushing really hard on RL.
Yeah, for sure. DeepMind has been very influential in this sort of research, and it does make sense in some case, to put forth that reward exhibition is really powerful for developing skills. At the same time, I still often think back to Yann LeCun's famous cake analogy, where he basically said that at the bottom, we have unsupervised learning, where you have the most information, the most signal, because you just have a ton of data, basically. Then you have supervised learning, where you have less data and you can get less information from your data. And then you have the cherry on top of reinforcement learning, where you get this very small signal of just reward. So I think we've been seeing that trend over the last few years, actually, where self-supervised learning has really been pushed with things like GPU-3. And I really think that, this trend of self-supervised learning combined with supervised learning and ultimately reinforcement learning will be something more and more common and, achieve even greater things than we've seen so far.
Right. And now on to maybe more applications. Our next article is titled "Carerobots Are on the Rise and Replacing Human Caregivers." All right. So this might not be a huge surprise, but as boomer generation is getting to an older age, the Biden administration has been, thinking very much about this and has proposed investing nearly $400 billion to provide seniors healthcare and personal care services at home. And so these care bots that, don't really look like robots necessarily, they could just be cameras with algorithms behind them, can help take care of older people. But they also, of course, control who gets what tests at a doctor's office and how many care hours are received by a person on Medicaid, and so on. And so I think there's this tension between surveillance and also, and I've done a little bit of work in this area. There's also this tension where, a lot of older people actually want something like this as opposed to going to a nursing home, because nursing homes are historically not great places and been a breeding house for abuse. And so some older folks actually would prefer a camera watching them, and they would be able to stay at home. And so this article discusses, a bit of the tension around, that surveillance and like AI kind of dictating what people can get, and especially those elderly people, and like the rise of these care bots as they become more and more prevalent to be able to serve this increasing population.
Yeah, I tend to agree. I mean, this is a little tricky in that, there's personal privacy. You can get to overuse use of algorithms where, the human is not involved enough and you have just algorithms running things. But at the same time, given the dire nature of the situation where, we have care workers, but they are paid not nearly enough, a median annual salary of $25,000, and it's very demanding work. And, with 50 million people over the age of 65 and just a growing population of that, we need better techniques to scale and to take good care of seniors who need help. So I think, I'm pretty optimistic and pretty hopeful that these sorts of technologies will, make use of AI for this positive cause and make this sort of care much better. And, maybe work with some of the things we discussed before of actual robots that are there for emotional support, maybe chatbots, anything that can not quite replace humans, but supplement them for kind of emotional support and presence, which I'm also maybe more optimistic about than many people. I think, even if you don't replace humans, having a way to supplement them, to aid them, is a very powerful idea that should be really adopted in many sectors, including this one.
Yeah, though I've also heard this joke that, we're replacing menial jobs with other menial jobs of just labeling data or like doing human in the loop. So it is a delicate balance. So we're hoping for, fingers crossed, a utopia with these care bots. And so our next article is from the Technology Review titled "These Creepy Fake Humans Herald a New Age in AI." And so this talks about deep fakes creating, or these synthetic people, deep fakes essentially, created by DataGen, as well as other companies. And what DataGen is trying to do is to create all these synthetic, data for helping with training data. So they're using, both 3D models and also AI to make it look more realistic and have, the skin texture, have little finer details. And we've seen that in a lot of synthetic data from generative adversarial networks, GANs, of course. But yeah, so they're trying to take this to, training data, because maybe there's not enough of certain data that has these realistic qualities. So that is what they're doing. And of course, the media's perception of this is, they do look, because they look uncanny valley, it is pretty creepy. So there's that. And of course, there's a privacy element of how do you know some of these people are not actually real and in your training data. So that's that.
Yeah, it's nothing that new. We've discussed these sorts of things in the past. And this article also notes that there's, a competitor called Synthesis AI, which basically does the same things. There's also other companies for generating data in finance, insurance, healthcare. And it just says that there are about as many synthetic data companies as there are types of data. And personally, I think this is kind of interesting because, how useful is synthetic data when you're really just generating more samples in the distribution? And I'm not sure how much it would add to the signal. I mean, we've seen in the past that synthetic data can improve learning, and this has been done in many papers. But ultimately, I don't know how much it can really help. I'm sure it can help some, but it seems like it's inherently limited. So I wonder how successful these companies can be, as opposed to these like data collection companies, data annotation companies, which seem possibly more essential.
Right. And I think, so on the bright side, they can help with things around bias, being able to have more examples in a certain age distribution or, weight distribution, ethnicity, et cetera. But yes, there's also the caution of, if it is only being trained on data on the real data that is only given by, let's say, one of their clients, then what can they do? Of course, I think if they pool data across a lot of different groups, then there's possibilities there. But of course, there are also risks of privacy there as well.
Yeah, exactly. So, don't know, interesting kind of overview of this topic. I would check it out if you haven't heard of this sort of thing, but not necessarily groundbreaking. And on to our next article, we are going to talk about a couple of things that are not as theoretical, more deployed and maybe impactful. And the first piece here is from The Verge, titled "Google is using AI to design its next generation of AI chips more quickly than humans can." So personally, I was pretty excited seeing this story. As the title implies, here Google is using machine learning to help design its next generation of TPU chips, and the algorithm's designs are comparable or superior to those created by humans, say the Google engineers, but can be generated much faster. And here they used reinforcement learning to train the model to be able to do it. An editorial in Nature calls this research an important achievement that really will make a significant impact. And I tend to agree. I mean, I think chip design is something that is super complex, and something that as chips get more and more complex is maybe starting to go beyond what humans can easily do. And it's already very dependent on programs to help humans check for various design flaws and things like that. And yeah, as far as I know, there's been research, but this is the first real application of it. So yeah, very impressive, and certainly something that deserves more hype than prior big stories like AlphaGo or something. Personally, I think, because I don't know, it's very cool to see this result.
I'm very excited about this as well. And I think there is, huge opportunity for AI to play a role in this. And I just want to shout out to the two co-first authors who are amazing researchers and women in AI, Azalia Mirosini and Anna Goldie, who are both wonderful people. So very much encourage you to check that out in Nature. And I really, really can't wait to see how this evolves, because I do think AI will do a better job than humans, or I believe that it can. This is like an area where I think automation could really come in and optimize for things that humans can't necessarily. So yeah, very exciting. And our next article is titled "Across China, AI, quote, city brains are changing how the government runs." And so just as the word city brain kind of implies, this is an AI system that's being used across China in megacities that can afford them. And this does everything from pandemic contact tracing to monitoring illegal public assemblies and river pollution. So it just monitors the whole city and has kind of a pulse on the entire city, a whole system that has a pulse on the entire city. And this very much, there are a lot of different, surveillance issues and just a lot of different issues that this could have, over privacy, et cetera. But at the same time, it also has a lot of potential to optimize for things and have these smart cities and have an understanding of what's going on in a city, and to hopefully make decisions based on that.
Yeah, I think it's easy to be cynical about this sort of thing and go to a dystopian place. But at the same time, I was pretty pleasantly surprised by this story and the kind of applications that were described. So for instance, there was an example where City Brain was used to control traffic lights in the city and increase the average traffic speed by 15%. There was also a note here that a City Brain makes it easier to identify administrative problems, faster to process complaints, and that it can actually curb corruption, that it can note, nepotism and can actually prevent it. And, in various countries, including Ukraine, which is where I was born, corruption is a huge problem. So, I think it's worth kind of noting the positives in addition to obvious problems of surveillance. And, given how often we've seen problems in government in various ways. And, just in general, everyone hates bureaucracies, right? Because of how, cumbersome it all is. I think this is pretty interesting. And I would be curious to see how these similar kinds of things pop up in the US or Europe or so on, because it does seem like these ideas are just too useful to not implement in some way.
Well, I hope the traffic thing comes to, the Bay Area, because I think we really need that. Any speed up would be greatly appreciated.
Yeah, every major city really could use this, I think. And on to our last story. This is our kind of always final, sort of more funny article where we see something that is less useful, but maybe more fun. And in this one, we have another article from Verge called "This 2700 Robot Dog Will Carry a Single Bottle of Water for You." So here it's describing this Chinese firm, Unity Robotics, developing a robot that's quite similar to the one from Boston Dynamics that kind of walks on 4 legs. And this robot, Unity Go 1, is pretty cheap. It only costs $2,700, right? So it's interesting to see this sort of continual decrease in cost and something we haven't seen too much in robotics. Something that's happened in drones, smartphones, etc., but not in this sort of technology. So that's cool. What's funny is that in their kind of commercial demo video, most of what was featured was a robot like running along with a jogger and carrying a little bottle. In the spec sheet, it says that the carry limit of these machines is pretty small. So in that sense, it was pretty funny. If you go to an article and read it and see the video, you can see why there was a bit of a humorous note there. But it is pretty serious aside from that, and pretty cool. Yeah, when you see this sort of robots, it's pretty impressive, and it's nice to see that they're getting cheaper, and that would mean that probably they would be utilized more.
Yeah, that was the biggest thing for me. I didn't realize how cheap it was. I was not expecting it to be under $5,000, so or even under $3,000. It seems like it's within reach for a lot more people than I guess often the tens of thousands price tag.
Exactly, and I'd be very curious to see whether these sorts of robots actually get used in industry. Boston Dynamics has been commercializing their robots, especially Spot, for I think a couple of years now, and they're available for purchase, for rent. And I don't know, I haven't seen kind of examples of their usage. There have been a couple, but I don't know how much impact they've had so far. And presumably this will be a long process, so a decade to really integrate them. But I'm pretty hopeful. I think these sorts of things are useful, and with effort and perseverance and commercialization, they will be put to good use and again aid humans in their everyday tasks, right?
Yep. And that's it for us this episode. If you've enjoyed our discussion of these stories, be sure to share and review the podcast. We'd appreciate that a ton. And now be sure to stick around for a few more minutes to get a quick summary of some other cool news stories from our very own newscaster, Daniel Bashir.
First off, a few stories on research. You've probably heard of LiDAR in the context of self-driving cars. Short for light detection and ranging, the technology uses lasers to measure distances and allow accurate mapping of spaces. While LiDAR is powerful, the data it produces overwhelm the data processing capabilities of systems in cars and other devices. But according to Datanami, MIT researchers are using an end-to-end machine learning framework that achieves a 9 times speedup over existing approaches to use 3D LiDAR data for mapping and to enable driving. Second, on June 11th, Facebook introduced a new AI research project that can copy the style of text in a photo from just a single word. As VentureBeat reports, Facebook claims Text Style Brush is the first unsupervised system of its kind that can recognize both typefaces and handwriting. Now for a few stories on the business and application side. As reported by Ars Technica, German automaker Volkswagen is considering charging an hourly fee of $8.50 for access to autonomous driving features once those features are launched. The company is considering a number of other features for its electric vehicles, including range or performance increases. According to Volkswagen's chief sales officer, a cost model that charges hourly fees could make autonomous driving more accessible than current options on the market. When you type a query into Google, it's not very often that you'll form it as an actual question. But as demonstrated in the recent Google I/O developer conference, that might become more frequent. As Wired reports, last month CEO Sundar Pichai introduced Lambda, an AI system developed to possess natural conversation capabilities. Google hopes that when Lambda is incorporated into Google products like Assistant and Search, it will change how billions of people search the internet. And finally, 2 stories about AI and society. Hate speech is one of the most pervasive issues on social media platforms today, and platforms like Facebook and Twitter have taken steps to tackle incendiary speech that include using AI systems to detect that speech. These AI systems are still quite faulty, but progress is being made. According to the MIT Technology Review, researchers from Oxford and the Alan Turing Institute developed a taxonomy of 18 different types of hate speech and identified 11 non-hateful scenarios that trip up AI moderators to better understand how these systems fall short. And finally, children are being exposed to AI-enabled devices like smartphones and iPads earlier and earlier in life. But the systems that tablets and other devices are built on aren't designed for children to easily navigate. In a recent episode of In Machines We Trust, the MIT Technology Review considers AI's relationship with kids. Thanks so much for listening to this week's episode of Skynet Today's Let's Talk AI podcast. You can find the articles we discussed today and subscribe to our weekly newsletter with even more content at skynettoday.com. Don't forget to subscribe to us wherever you get your podcasts, and leave us a review if you like the show. Be sure to tune in when we return next week.